Hello everybody, my name is Gazihan Alankus, and today I'll talk about Flutter and asynchronous code in it. So I am from Turkey, probably the only Turkish person except for my lovely wife here. And luckily our friend also speaks Turkish, so it was a really surprise to me. Apparently he was an exchange student. So I'm from Izmir in Turkey. I am an assistant professor in Izmir University of Economics. At the same time, I have my own company where we develop Flutter applications, mobile applications, and web applications with Flutter. And I'm also a Google developer expert in the Dart language, which is the language that Flutter is built with. So, and you can find me in these places with Gazihan Alankus handle. And I'm really happy to be here. Thank you very much for accepting my talk. And so I wanted to structure this talk. Initially, it was like a little more advanced, but I wanted to structure it so that if you're even curious about Flutter and just wanted to hear something about it, you'll find some things for you. Even if you don't want to use Flutter in other domains as well, asynchronous programming is important. So I think everybody will get something out of this talk, I hope. And I'm glad that it's recorded because I'll be sharing it with my students because they cannot find this information condensed sometimes like this. Okay, so let's make an introduction to the topic asynchronous programming. What do we mean? Let's imagine that we are going to the mall and we want to buy pizza, and we have to wait in a line for 2 minutes. Okay, we wait. And then we buy jeans, we go to the tailor shop to get the legs adjusted. 30 minutes, okay, maybe we still wait. And we drop off our suit to the dry cleaner shop. They say 2 days. Do we wait there? Obviously not. So do we really wait? How do you decide if you're going to wait? What do you do instead? Even if I'm waiting for the pizza, what do? I just take out my phone, fill in the empty time, right? So we're always switching between tasks in our real life. We're not just waiting for something. Okay, you're going to give me pizza. I'm looking at you, right? We never do that in real life. But in programming, we do that. So we'll try to avoid that as much as possible with this idea. So I hate when I lose time waiting in front of a restaurant like this. In some restaurants, they give you a little device, and in some self-serve restaurants again, they give you a little device. You sit down, you do your other things, and then when it's ready, it buzzes and you get your food. So this will be our future object or promise object in this talk, analogy for it. So if you don't want to wait, you need something like this device or an IOU, like a receipt that says he's going to get his jeans, or like a box that says this box will contain your answer. It will open by itself when it's time. Don't try to open it yourself at the moment. So you cannot get the answer right now, but something is given to you that will let you get the answer in the future. Okay, there are a lot of Stack Overflow questions about this, so you have to understand it really correctly. You cannot get the answer right now. You can't do anything to get the answer right now. You have to embrace that it's going to happen in the future. So keep that in mind, that analogy of the buzzer. We'll come back to that. So let's talk about synchronous versus asynchronous with an example. So I want to cook dinner, and I want to do beans and rice, and what do? Do I just cook the beans, all the beans, and it's perfectly ready, and then start doing the rice? No, I interleave them, because if I do it like that, there's a lot of time wasted, right? I prepare the onions, fry the onions, and wait for the onions to fry, wait for the water to boil. I don't do that. If I do that, I lose a lot of time, I waste a lot of time. What do I do instead? I interleave them in an asynchronous manner. I start the onions and then switch to here, do something here, go back to the onions, etc. Asynchronously, I get my work done. But in programming, like I said earlier, we do this a lot. So we are trying to avoid that. And if you actually look at the busy time here, it's much less than the whole time you would waste if you did it synchronously. And at the same time, you have a lot of empty spots in which you can be responsive to other things. For example, I'm cooking dinner and my wife calls me. I'm not going to say, okay, I'm waiting for the water to boil. I cannot answer the phone, right? But unfortunately, that's what happens in some apps sometimes. The app is waiting for something else. It's not very important. So Outlook is not doing like a scientific calculation that it cannot respond to your touches. It's just waiting for something somewhere, like a file system, like network. It's just waiting for it and ignoring you for the time being, right? So it's because this is written in a synchronous manner, that specific code. It's kind of like an old screenshot, but it's nice to bash Microsoft. So if you do it asynchronously, you waste less time and you stay responsive. And in this specific example, the UI thread is blocked, so it's ignoring your touches for a while, and your OS says, hey, this may be a dead application. Do you want to wait or kill it? So we don't want to do that. So the first thing that may come to your mind is, okay, what about threads? Can we use threads to get out of it? Yes. If you do it skillfully, in theory, like if you're really professional at it, if you really do it well. But most of the time when you dive into threads, it's like a messy kitchen. You know, everybody is taking everybody's stuff, and you cannot write 2 lines without assuming that somebody can get in the middle. So I don't like writing multi-threaded code, and it's usually a mess. So why? Because first of all, it's not a lot of gain to get a new thread, because you get one guy waiting for the water to boil, you get another guy to wait for something else sometimes. So both of them can be waiting sometimes. Still, it's a waste of resources. At the same time, when they are working at the same time, they can be messing with each other's stuff, so you have to be careful about race conditions, etc. Right? So it's not the ultimate solution to everything, running threads. And you know, you have a limited number of threads also. In the async world, we have only one thread in Flutter Dart, but that thread, you start a function, and when that function is going to wait for something external, like a network call, it just drops that, and it creates another function, attaches to that network request, and when that comes back, it continues with that other piece of the function. And in the meantime, it can go start yet another function, right? So interleaving the tasks. To continue your work, you have to have another callback function that will help you get back to the task at hand. So how do we, I gave you some tips there. How do we get back to what we were doing, right? In a thread, in a synchronous world, it's easy because you're at line 1, line 2 you go to, it's doing a network request, it just waits there, and when it's over, it goes to line 3, right? That's how you wait. It's very easy, it's just very convenient for the programmer. But in this kind of a situation, you have to create another function that will be called by the network system when the network thing is over. So it's more inconvenient for the programmer. That's why we sometimes do this, right? We need a callback function for that. So let's zoom in here. If we create callback functions and everybody gives everybody a callback function, it's very closely coupled system. Everybody knows about everybody. So instead, what we do is we have these future objects, or you may have heard of as promise objects, that are like the brokers between the producer and the consumer. So the producer, I start the blue task, and then when this network request starts, the network call gives me a future. Hey, this is your box, or this is your buzzer. When it's ready, it's going to buzz, so you can continue with it. So I attach my function to it, and when it is ready, when the data arrives, it calls my function, and that's how my task continues. And in the meantime, I can do other things. So this is basically how asynchronous code works. This is all handled by the event loop. There's a really nice video series by official Flutter people. So this and this are events, just like touch events that I have in my system. These are events, and there's a main loop, event loop, that's taking care of these. So as you can see, as I'm doing this, I have my thread idle a lot of times, and I'm able to handle touches really quickly compared to like making it wait and then app becoming unresponsive, right? So these are all regular events that are being handled in the event loop. When the event loop finds time, it just gets the next event from the queue. If these executions are short-lived, they don't actually wait for something external, then they will be able to quickly finish and then respond to user touches. Answer your wife's call rather than watching the water boil. So the sync alternative, let's remember that. My line 2 would be waiting here, and the touch event comes. It just sits in the queue because I'm not letting go of the thread. The thread cannot go into the event loop, so it cannot handle it for a while, and you feel your app is unresponsive. It's not reacting to your touches. So if you did it in an asynchronous world, it wouldn't have been the case. And the whole thing about Flutter is it embraces this structure, Dart and Flutter. So it makes it really easy, really convenient to write asynchronous code. You can write that kind of code like handlers, etc. in any language, but Dart and Flutter makes it really, really easy, really, really convenient. So you do that. Actually, you cannot even do the synchronous case in a lot of cases. It forces you to be like this. So I'll explain how. So we have these future objects, right? I talked about these future objects that are like the broker between the producer and the consumer. They don't have to know each other much. They're just interacting with the future object to tell the other guy something, right? The producer says, here's the future. I cannot give you the result right now, but here's the future. I'll give you once I'm done. And he says, okay, great, I know what I'll do when it's done. Let me attach a function to it, and then let's move on. This guy creates the result. This guy does other things in the meantime. And he's like, yes, here's my result now. And then he's like, okay, I have attached a function to it. It's executing now. Let me, in that function, let me use whatever you sent, right? This is more or less what's going on between the two. There's error handling, etc. I didn't put it into this talk, but it's quite trivial, quite straightforward. So this table is nice. So for futures, we have like int types, and then for the future type, you'll get future int, right? For int value, we have a future int. For string value, we have a future string with the generics. So here's some code, very simple code. This function returns 1, and then I get that value, print that value, right? Synchronous. If it was asynchronous, my function would have to return a future int, and somehow create some kind of future, maybe that completes after a couple of seconds, and then return that future object. And getVal now returns a future object. Future object has the then method. You can say .then, and then you can give an inline function like this that will be executed when that future completes sometime in the future. Okay? So as you can see, this is a little different. Here you have your main function executes immediately and returns. And then this function, this inner function here, like a closure, it will be executed when the future completes sometime in the future. Okay? Not right now. So it's important to understand this distinction. This is for single values again. So we also have something for multiple values. So these are called streams, stream class. It's very much the same thing, except you get multiple values in the future. So it's not just for one, I'm requesting one thing. I'm like following a live update from Firebase, or I'm getting all the key presses in time from the user, right? Some data is flowing, you don't know when, you don't know how much, how many. You are just ready to get whatever in the future comes. So multiple of the future, the stream object. So in this table, we see a single value here. And for multi-value, we have the stream for the async. The sync version is iterable. It's like the list, array, whatever. This is the parent class of those. You can do a for in loop in an iterable, or move next, etc. You can do. So if you have an iterable, you have a list, you can do a for in loop. You can go over them in a synchronous way quickly. But in the async world, with the stream, you have to have .listen, and similar to the future example, you have to give a handler function, callback function, that will be executed every time you receive a value, right? Okay. So this looks good. This is what we're supposed to be doing. Okay, my mom tells me be a good boy, etc. But it's not convenient, as you can see. This is more convenient than this. So it's like something that you should be doing, but you're not doing because it's not convenient. It's not easy, right? We don't have that in Dart actually. So in any other language we would have that, but in Dart. Synchronous code is easier, we would say, but Dart language and the standard library have async support. So what do I mean by that? So if you open a file in Dart, you get a future from the standard library. You don't get the file handler. In any other language you can think of, if they give you a file handle and you read a line from the file, they do it synchronously, they are losing time because the file system is much slower than the CPU. So the CPU is like watching the water boil in that case, waiting for the file to be read. In Dart, you don't have a synchronous option for file reading, for network, etc. They all give you a future. So they're all async functions, the functions that you use in the standard library. So it forces you to be async. Okay? You cannot be sync, you cannot write bad code in this way in Dart. And the language also makes it really, really nice. It actually looks like synchronous code, the async code that you write. So you don't deal with callbacks. And we will see that soon. We have the async array keywords that let you write async code that looks like sync code. We have sync star, async star that lets you create an iterable stream really easy with single function that uses the yield keyword to send over values. So let's look at our single value future example again. So this was our sync code. This was our async code with the handler callback function. And this is our Dart syntactic sugar added to it. So as you can see, it looks very much like the sync code, right? Intval, getval, intval, await getval, printval, printval. So it looks very much like the sync code. But this is actually async code. This works like this in the background behind the curtains, okay, under the hood. So what's different here? Let's see. So if your function is returning 1, your async function that will return something in the future also returns 1. So there can be some time-consuming things before that, of course. And if you mark your function with async right here, it automatically has to return a future of this type. But you don't return a future, you return the type itself. It automatically wraps it in a future and gives it to you a future when you call it. So when you call it, you can call it like this still. So you can call this like this still. But you can call it like this, which is better. If you're in an async function, if you're in a sync function, you have to call it like this. But if you're in an async function, which your main function even can be, you call it and you put the await keyword in front of it. Await just unpacks the future, but does something magical, it goes to the future, right? You cannot unpack it right now. So actually, this is exactly what's going on. The rest of this is another function actually, but it hides that complexity from us. I write it like a synchronous code. I write it like synchronous code, and then it actually executes asynchronously. Okay? So this is really cool. Your code looks like synchronous code. You have your local variables, etc., loops, etc., all there. And then it actually does this behind the curtains. Try-catch also works nicely, etc. You can have multiple branches. Some of them do async, some of them don't. So really, really nice. If you embrace this, it's a lot of fun to write async code. Any questions? You can always stop me, by the way. I hope this is clear. Your async code looks like sync code. So what about for the streams, right? We said that you can do a for loop on an iterable, and this was our old code. You can listen to a stream. You can also do an await for on a stream, which is just like for. If you're in an async function, you get a stream, you say await for, and the rest is just like the iterable, but this is for a stream. So what happens here? Every time the stream gives me a value, this for loop does one loop, and then it waits here. And then every time the stream gives me a value, it does another loop. Also in the event loop, etc. So it doesn't block anything. It says await, etc. But it doesn't. The concept of the task is waiting, not the main thread. Main thread is doing other things. Well, this job is waiting here, right? So the main thread is not actually waiting. Sometimes people get it wrong when it says await. Is it inefficient, etc. Quite the contrary. Okay, so this is really nice. Looks like the sync code, but it's actually async. It doesn't block the main thread. Okay, so let's talk about how we can create these streams a little bit. There is more syntactic sugar in Dart for that. You can create a simple function that will create an iterable or a stream for you. That function is over here. It automatically, the values, you pass them using the yield keyword rather than the return keyword because there are multiple ones of them. And it automatically wraps that into a stream, and that stream, whatever value you give, that stream emits those values. So it automatically creates this stream for you. And writing this makes you create a stream automatically. You don't have to, there's a stream controller, etc., all those classes that you set up. You don't have to do that. You can just use this generator pattern. So here's a sync versus async generator. Here's a sync generator. This creates an iterable. You don't want to put them in a list. You want to create them on the fly, but still you want to do it synchronously. So what happens here? Every time the for loop loops, this goes to the next yield. Every time the for loop loops, this goes to the next yield. So for loop is in control, and it runs really quickly. This goes through these yields, and then you looped over the elements that this generated. In the async version, your code looks very similar, but now the stream has control because the stream knows when the data will arrive, right? You cannot force it. So whenever there is some async delay, maybe a network call, whenever a data is available, when it says yield, this turns once. When it says yield, this turns once. When it's over, this gets out, right? This had control over here, and this had control over here. So it's but still you're doing a for loop, which is really cool. It's, I had written like socket applications before with event handlers, etc. And when you do it like this, it's like, oh, it's so much fun. Like you keep your state in local variables, and you can do all kinds of language tricks there. So it's a lot of fun compared to the other way around. And this works like really quickly in the same call, as I said, but these work in different times as new data comes in. This goes and comes back, which is what I just explained. Okay, so far for Dart. Dart is a language that embraces asynchrony, is, I hope, what I try to explain. Let me also check my time. So what about Flutter? Does Flutter have something special that helps this process, right? Flutter is written in Dart, all this is there in Flutter, but Flutter is more than a language, it's a framework of UI, right? A UI framework in which you do some user interactions. What's there in Flutter that helps us do user interactions? Because if you don't have your data, you cannot create your UI, what do you do? So Feature Builder and Stream Builder widgets are there to help you there. And you can also do it in a custom way using the set state when the feature stream is complete. I'll be talking about these in the upcoming slides. I just want to say there is a block pattern, it is called. If you're new to Flutter, sometimes it seems like you need to learn this thing. You don't have to. It uses streams heavily. It makes testing easier. But it was initially created so that Angular, Dart, and Flutter could share code. So this makes things a little complicated, especially if you're a beginner. Try to stay away from it. Because I see on Stack Overflow, obviously a beginner doesn't understand streams, but he's trying to do something with the block. And it's very difficult to explain what needs to happen there to them. So we're not going to talk about it today. But let's talk about the Flutter architecture. So if you've never worked with Flutter before, let me explain it briefly. You have for your UI, Flutter is a UI framework. You create mobile applications, on web applications, desktop soon applications with it. Your UI is a tree of widgets. There's a widget class, and there are a lot of other classes that derive from the widget class, and they form up a tree structure. And this is rendered by the Flutter engine, and you see it as UI elements on your screen. So this is more or less what's going on. So when you build this tree, you see it as a UI in your mobile application. Okay, it's all widgets, it's good. But if you have the data, it is the case, right? If you don't have the data, what do you do? Because the data did not arrive yet in future cases. So for that, we have Feature Builder widget, just like any other widget, like text, etc. We put a Feature Builder widget in the tree, and then we give it a feature saying that, okay, when the data arrives, this feature will let you know. And the Feature Builder gives you a builder function in which you can say, okay, if there's no data yet, let me create a loading widget. So circular progress indicator. If the data did not arrive yet, let me create that, put that into the tree. When the data actually arrives, my function gets executed one more time, and then I can actually create my UI widget hierarchy there and create whatever beautiful thing that I want to show to the user, right? So there's this feature builder that you can stick into the UI tree, and that manages what's going to be under that using the features. Similarly, Stream Builder is also there. Very much the same idea, but every time a new data arrives, this Stream Builder rebuilds this part of the tree. So this is like if you played with Firebase, you make a synchronous connection to the Firebase, and every time a user updates it, you automatically see it in your UI changing. So the stream sends the data over, and then you see the new data on your screen. Or whatever is happening, like any stream that's feeding you data, you can show it live in your UI. So Stream Builder and Feature Builder, and here is some code. Of course, I have to show code, but yeah, maybe like this. So this is a build function. This is when your widget is trying to create what's going to be under it in the tree, right? So in this build function, I try to create exactly this. Over here, it starts over here. I have the column, and its children. One of the children is Feature Builder. One of the children is container with text right here. And I have the Feature Builder as the first child of the column. And the Feature Builder gets a feature. I should have initialized this in a previous call in the init state or somewhere like that. I give this feature to this, and then give this builder function to this. As you can see, it can be a little complicated to see sometimes, which I'll talk about soon also. So this snapshot contains information about what the feature is giving you. Initially, well, it can have an error. Some errors can happen sometimes. You have the option to show it to the user or do whatever you want with it. If the snapshot doesn't have data, then you get to show a loading circle progress indicator, etc. So this is getting called whenever snapshot changes. If neither of this is true, so that means you have data, valid data, then you build your tree, and then it is displayed on the screen nicely. Similarly, for the stream builder, nothing much changes. You have from somewhere you get a stream, and then similarly you build your UI. Pretty much almost the same, yes. Okay, there's an alternative. You don't have to use the future builder because sometimes people look at this, okay, what's going on here? I just want to see my UI elements. You do have an alternative in which in your widget, in the init state, you start an async job, and then you call a start async job. This is an async function. This init state has to be a sync function. It has to be a synchronous function because the widget tree cannot wait to be created. But in it, you can initiate an async function like this. You just throw away the future that you get. So like a thread, this runs in the event queue. And you try to obtain some value from the network, let's say. And until it comes, your build function will be executed, of course, with state is equal to null. There's a state variable somewhere. And it returns the loading circle progress indicator. When this await goes to the next line, you have the R value. Then in the set state call, this tells Flutter, hey, our data has changed. Let's update what we have on the UI. So build function is called again with state not being null this time. So it goes to here this time and creates your UI. So I'm actually trying to show you here. So initially, when this first executes, this executes and returns. So yeah, this lets it go. This part doesn't execute yet. And then state is null, so you see loading. And then when this R comes in, you call set state like this, and then build is called again. So you create your UI like this. So in this case, you have full control over your future. And when data comes in the future, you call the set state, and you update your UI manually. Sometimes I like this pattern a little better. It's a little more cleaner than this sometimes. But there's a caveat here. A lot of people start doing this, and then they get random errors related to widgets being unmounted, especially if your screen is a little crowded. It can be difficult to detect that. So here is the tip for it. I told you I'm going to make my students watch this, so this is where it comes. So sometimes your widgets will get unmounted. So there's this user info widget on the screen. Maybe user swipes somewhere else, maybe goes to another page, maybe the page for some reason decides to take it out, right? Dart code doesn't know about that. Dart is just a function, it's being executed. So it keeps running this start async job, even though the user info widget is not in my widget tree anymore. So when it tries to call set state, you get an error. The error actually tells you, okay, you tried to call set state in a widget that's not mounted anymore, etc., etc. So as a rule of thumb, what you do is whenever you have an async job that will be doing set state, that will be changing the UI, you should be aware that you are now in the future and maybe you are not relevant anymore. So you should protect about that. I have this set state if mounted function that I create sometimes. If mounted, set state I say. If not mounted, just don't do anything. This kind of protects. You just don't do the set state, everything else keeps working. But sometimes this may be bad because if the UI element is gone, maybe it's gone for good. Maybe you shouldn't be doing anything else. So you can also do if not mounted return after every await, right? I just awaited for something. I'm in the future now. Maybe I'm not mounted. If that's the case, let me destroy what I have started, right? So this pattern is quite useful, and it's, I didn't see it in many places. So kind of like as we build apps, we are finding these things out. Yes, so, and this is the full code for it. So we have a counter here, fast counter, and this is the state class of it. In the init state is called initially when you first create the widget. We call start counter. This is an async function. This returns me a future, but I don't care. I just initiated it. It will execute. I don't care when it finishes. And this is doing while true, as you can see, quite dangerously. And it will keep doing this. What is it doing? It's creating a future that completes after a while, increases the counter, but doing it with set state if mounted. So protecting against that error. Perhaps I should have done if not mounted return to break the while loop also. That would have been better in this example. And in the build function, we're just writing down what counter is on the screen. So every time this turns, because of this set state, build function executes one more time, and then you see it on the screen. So you have to protect against set state after and await. This is one of the rules if you're going to handle your own futures yourself. Another way to get that future builder a little cleaner, I showed you earlier the future builder code. Let me show it again. So it's a handful. So like all this boilerplate kind of code makes it kind of hard to see the UI code. So what I do is I use the local or nested functions of Dart. Dart has nested functions. In the build function, I can create a really build function. So the build function creates a stream builder. This is the boilerplate for it. If it's not ready, create a circle progress indicator. If it's ready, then build it, etc. Then call really build, yes. So I separate the actual UI part to another function, but I don't want to put it in my class because it will crowd my class. I put it inside my function as a nested function, so it's not going to crowd around. But this is clearly, when the time comes, this UI will be created. So it makes it a little clearer to see. And this, as it gets longer, as it gets, nested future builders, stream builders, it can become quite complicated. At which point you probably should be creating your own widget classes anyway. But this I found to be a nice pattern. Okay, one other thing that people need to be careful about. And this is such a issue that official Flutter videos even have this problem, unfortunately, because this code versus this code, this is nicer to show when you're first teaching the concept, right? So what do we have here? What am I talking about? Build functions can be called many times for various reasons in Flutter. So you create a widget, and it is supposed to, stateful widgets, they are supposed to have a bunch of variables in them, and those variables, you will change them, but you will write a build function that will reflect the values of those variables in the UI. Sounds pretty straightforward, but you're tempted to put into the build function things that will do like network requests, make decisions, etc. You don't do that. This is like a mathematical function. You get these values, you show these UIs, okay? So your build functions have to be like that in Flutter. When if you're a beginner, when you learn about it, make sure you remember this. Your build function has to be a very simple function with no side effects. You get your values, convert them to UI. No other side effects. If you create other side effects, all kinds of issues you run into. So this example, for what does it do? Let's try to understand it. There is the build function in which you're supposed to be creating the UI for this widget. We have a future builder because we will do something that takes time. And the wrong thing that we're doing is we're calling the HTTP call here. So what happens when I call HTTP call? It creates a network request, gives me a future, okay? And as you can see, this HTTP call is actually being called in this build because I need to create the future builder, and one of its parameters is the HTTP call, so I have to call that first and then give that its result to the future builder constructor. So when I do this, Flutter does not make any guarantees about how many times it's going to call your build function. It can call your build function for a number of reasons. It's always supposed to be, without any side effects, data converted to UI. But if it calls it one more time, what happens? You create one more HTTP call, one more call to your server, one more call to your server. Who knows what? You switch between apps, one more call to your server. Something pops up, one more call to your server, right? This is an easy way to get your builds stacked up in your cloud side. So you shouldn't be doing this because this is creating an HTTP call as a side effect in your build function. It's not supposed to be happening. This is the correct version. You create a future. Remy Rezulay has a really nice Stack Overflow answer about this. He asked the question and answered it himself. You have a future that's cached in your class, in your widget as a field, and in its state you create the HTTP call. So when the widget is first created, you make a HTTP request and hold on to that future in your class, in your object. And in the build function, like I said, I have data, let me convert it to UI. this is my data, I'm waiting for something, let me convert it to this future builder. Even though, you know, this gets rebuilt, this is called again, it's called with the exact same future, so it's not initiating something new, it's still waiting for the same thing. If it already arrived, it shows you again what arrived, okay? So this is a tricky thing we see on Stack Overflow all the time, people getting confused about this. Even I sometimes find myself, why did I call this in the build function? So you have to be always reminding yourself, because this is a little different way of programming compared to the other ways that you might have been used to. Okay, so happy async programming is what I'm going to say to close. I finished a little earlier, but if you have questions, I'll be happy to answer. How many people used Flutter before? I was scared to ask it before because I was going to, yes, okay. I'm glad that, you know, I spent more time in the async stuff because it's useful in any domain really. So async task there is in Android, which has some problems recently. So in any domain, you shouldn't be hogging the main thread. Whenever a network request happens, whenever you read a file, which is the more often the problem that's made more often, because if the file is large, if you're maybe doing random access, etc., that will take some time, and that will actually make your app unresponsive sometimes. But in Dart, everything gives you a future, so you don't have to worry about that. Okay, if no questions, then some resources. These are Andrew Brogdon's Async Coding with Dart Flutter in Focus series. It's very useful. But it does have this issue that I told you about, so just remember that, because, you know, showing this would be worse than showing this in a nice, polished video. Florian Loisch this video was the thing that made me wow when I was trying to learn this stuff from 2015. And asynchronous programming in Flutter with Dart, yours truly's presentation in our university. If you want to watch it, you're welcome to. And yeah, this is pretty much it. If you want to get in touch, like I said, my handles are Gazihan Alankus. You can find me anywhere, follow me. And we are developing mobile applications, so if you need help, maybe we might also be able to help you. So thank you for listening. Thank you for having us here.